Hello, am I audible? Hello,
Yes, you're audible.
okay. Is my screen visible?
Yes.
Okay, thank you. So, good evening, everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. And this is my seventh live session. My name is Awan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So, in this live session, we will discuss and solve some practice problems on week 7 topics. So, in week 7, evaluation measures and boosting and bagging topics were covered. So we will discuss some practice problems on these topics, and also I will try to clear your doubts and answer your queries. If you have any, please feel free to ask related to any of the topics of this week. So we can start solving some practice problems. So this is the first question. You have two binary classifiers A and B. A has accuracy 0%, B has accuracy 50%. So which of the classifier is more useful? There are four options. First option is classifier A, second option is classifier B, third option is both are good, and last option is cannot say. So A and B are two binary classifiers. So they would predict only two target output levels or classes, and the first classifier A has accuracy 0% and the second classifier has accuracy 50%. So in that case, which classifier would be more useful? You can write your answers in the chat. So Aditya Chauhan has written option D, which is cannot say. Okay. Pratik Tiwari is saying depends on class. Anyone else? Pratik is saying number of classifiers. So any other answers? Depends upon number of classifiers. So the question is, there are two classifiers A and B. A has accuracy 0% and B has accuracy 50%. So first classifier is A, second classifier is B. First classifier has accuracy 0% and the second classifier, which is B, has accuracy 50%. Raghav is saying B. So the correct answer here would be option A, because it is a binary classifier, so there are only two output classes possible, positive, negative, or 0 1, whatever you say. So there are only two classes, output classes possible. So classifier A has accuracy 0%. That means it is misclassifying every example or every sample. So that means if we just flip the output of classifier A, we will get the correct output, isn't it? If the classifier A says it's positive, then a positive class, we will flip the output and it becomes negative class. Or if the output of the classifier A is negative class, we will flip the class and we will say it's positive. So if we just flip the output of the classifier A, in that case we get all the correct outputs and accuracy becomes 100%. So we just have to take the opposite of whatever the classifier A predicts. But in case of B, it is very much random, isn't it? 50% accuracy rate, that means it is just like tossing a coin. It's random. We cannot rectify this output of B at all. Just like we can do this for classifier A, we can flip the output and becomes correct because it is always misclassifying. But we cannot do the same for option the classifier B, because it is random. It is like random output from classifier B, 50%. So we cannot do the same for classifier B. So using that trick, we can correctly classify all the examples. So the correct answer would be option A, classifier A. So classifier A is more useful. We can just flip the levels and we will get 100% accuracy. Is there any doubt on this question? Mr. Pandey, can you please explain? So this is A and B both are binary classifiers. That means output levels possible are only two output levels, like positive, negative, or 0 1. So if the accuracy is 0% for classifier A, that means it is misclassifying every example. So if it says if it predicts positive class, we will flip the output, it becomes negative class, and that is correct because A has 0% accuracy. That means just flipping the output of classifier A, we will get the correct output. And but for B we cannot do that. B is 50%, though the accuracy is higher for B than A. The problem with B is that we cannot rectify the output of B and increase its accuracy. We cannot do that because 50% means it is randomly assigning levels. But we can rectify the output of A because we know that the accuracy is 0%. That means it is misclassifying all the examples. We will just flip the output level and becomes correct for all the examples. So we will get 100% in that case. Mr. Pandey Singh, I couldn't get flip the level. So binary classifier means you have two outputs, 0 and 1, or positive class and negative class. So if the classifier A say predicts class 0, we will flip the level and we will say that it would be class 1. Or if the classifier A says positive class, we will flip the level and we will say it is negative class. So whatever A would predict, we will take the opposite class. In that way we can get an accuracy of 100%. Question 2. Sensitivity is same as precision, recall, specificity, none of the above. Pratik Tiwari is saying option B, Mr. Pandey is saying option B. correct answer is recall. Recall is same as sensitivity, and formula for recall is true positive divided by true positive plus false negative, and this is same as sensitivity. So sensitivity and recall are same. Question 3. Using the bootstrap approach for sampling, the new dataset will have dash percentage of original samples on expectation. And there are four options: 50%, 56.8%, 63.2%, and 73.6%. So by using a bootstrap approach for sampling, the new dataset that we will get will have how many of the original samples on expectation. The bootstrap is same as bagging approach. So as in case of bagging we do sampling with replacement, same approach is done in bootstrap also. Pratik is saying option C, which is 63.2%. Has anyone else computed this? So the correct answer is option C. So how can we do this? So in bagging we use sampling with replacement, and it has been also shown in the video lectures that the probability of a training example not getting selected in any of the samplings is 1 minus 1 by n whole to the power n. So this is the probability that any given training example will not be picked in the bagging approach or bootstrap approach during sampling. So if the value of n is large enough, so we can simply take the limit of this, n tends to infinity, so it would become e to the power minus 1, which is around 36.8%. so that means this is the probability that any one training example will not be picked in the sampling in bagging. So so on expectation 100 minus this will be picked. So this is the probability that a training example will not be picked. So on expectation 100 minus this 36.8% will be picked, which is 63.2%. So this is how you calculate this. So this is the probability that you have to remember. So this has also been taught in the class, that this is the probability that a given training example is not picked during the sampling process of packing, and that probability is this 36.8%. that means 63.2% is the probability that it will be picked. So on expectation the number of training 63.2% examples from the original dataset will be picked in the sampling. So this is how you will calculate this. Is there any doubt in this question? So now we move on to question 4. You have a special case where your data has 10 classes and is sorted according to target levels. You attempt 5-fold cross validation by selecting the folds sequentially. What can you say about your resulting model? So there are 10 classes in the dataset, and it is sorted according to the target level. So like first all the zeros, then all the ones, then all the twos, like this, finally all the nines you will get. And also consider that the number of examples or samples for each class is same, and you attempt 5-fold cross validation and selecting folds sequentially. So what would be the what can you say about the resulting model? It will have 100% accuracy, 0% accuracy. Accuracy depends on how good the model does, and accuracy will depend on the computing power available for training. So Raghav is saying option B, Pratik is saying option B, Sankar Lal is also saying option B. So I've got 3 answers. All 3 answers are option B, 0% accuracy. Anyone else? correct answer is option B, that it will have 0% accuracy. So the reason is that so the first we will have all the zeros, then we will have all the ones, then twos, like this we will have all the eights, and then all the nines we will have. And you have to do 5-fold cross validation. So that means this last two classes, if we consider that the number of samples for each class is same, so in that case these samples are used for training, and this will be used for validation. So this first the first 4 folds, these are first 4 folds, and this is the last 1 fold that would be used for validation. So this first 4 folds would not contain any examples of class 8 and class 9, and because all the class 8 and class 9 examples are here in the last fold, and this last fold is used only for validation or testing. So after training it, the classifier doesn't even know that there are 2 other classes 8 and 9, so it would never predict 8 and 9 during validation. So it will misclassify all the examples in the validation set, the last fold, and it will produce an accuracy of 0%. So this is the accuracy would be 0% for this classifier. So this happens because the data set is sorted by target levels. If it was randomized, in that case it would not have happened, but as the data examples are sorted according to the target levels, and also we are considering that each target number of samples in each class is same, so that's why the last 2 classes would never be used during training, so it would never be able to predict the class 8 and class 9 during validation. Pratik is saying, if you can think of any example where we can use bootstrap over cross validation and vice versa, and one for when to use leave one out, if you can think of any. No, I mean bootstrap over cross validation, I couldn't understand your question. Cross validation is an evaluation measure. It's a performance metric for your it's a method for finding out the performance metric or the accuracy of your model. And bootstrap or bagging is an ensemble algorithm, so it is to strengthen your algorithm basically, or strengthen your classifier model. So those two are two completely different things. Cross validation is a method for evaluating your classifier, and bootstrap is an ensemble method where you combine many classifiers to produce the final output. Yeah, bagging and bootstrap are same, and cross validation is a completely different thing, so I couldn't understand your question properly. There is no relation between cross validation and bootstrap or bag. Cross validation can be performed on any classifier to evaluate its accuracy measures and other performance metrics of that classifier, and bagging is bagging or bootstrapping is an ensemble method to produce better classifiers, combining multiple classifiers. Now question 5, Pratik is saying for leave one out. I'm not able to understand your question properly. Can you unmute and ask your question properly? In cross validation, can we do? Yes, in cross validation we can do leave one out. In case of k-fold cross validation, we are training the classifier in the first k minus 1 folds, and we are leaving out the kth fold, and then again take the other k minus 1 folds for training, and we are leaving out the kth fold. In that way we repeat this process for k times. So this is how we are leaving one fold out just for validation, and we are training on the other k minus 1 folds, and repeat this process for k times. So this last fold, we are not training on this last fold. So this is, we are actually leaving one out, leaving one fold out. We will test only on the last fold, and we will train on the other k minus 1 fold. So question 5. So this table is given, which contains actual positive, actual negative, predicate positive, predicate negative. These values are given here. So you have to compute precision and recall from this table. And 5 options are given. Last option is none of the above. So basically from this table you have to find out what is the value of true positive, what is the value of true negative, and what is the value of false negative. So these are the 3 main things that you have to find out from this table, and then you use these values to compute precision and recall. So I have received 3 answers in the chat. All 3 answers are option D. So precision is 0.7 and recall is 0.4375. Has anyone else computed this precision and recall values? Raghav is also saying option D. Vinaya is also saying option D. Okay. So for this question, from this table, first you have to find out what is the value of true positives? So true positive basically means that the number of trading examples or the number of examples which are actually positive and also predicted positive. So that means actually positive and predicted positive. So this is 35. So this is the value of TP, true positives. And then you have to find out the value of true negative. So true negative means sorry, not true negative, precision is TP divided by TP plus FP, so false positive. So you have to find out the value of false positive for precision. So false positive is which are actually negative but predicted positive, so which is 35. So these are false positives. So that means precision would be 35 divided by 35 plus 15, which is 35 divided by 50, which is 0.7. And for recall, you have to find out TP divided by TP plus FN. So false negatives. So that means which are actually positive but predicted negative by the classifier. So this is this 45, which is which are actually positives but predicted as negatives. So this is false negative. So this is 35 divided by 35 plus 40, 45, and it would be 0.4375. So option D is the correct answer here. So precision and recall, this is how you have to calculate these two values. Question 6. Suppose you have 10,000 emails in your, suppose I have 10,000 emails in my mailbox, out of which 200 are spams. The spam detection system detects 150 mails as spams, out of which 50 are actually spams. So what is the precision and recall of my spam detection system? So 200 are actually spams, but the system detects 150 as spams, out of which 50 are actually spams. So if this is the scenario, then you have to what are the values of precision and recall? Raghav has written option C. Pratik is saying option A. Okay, Raghav changed his answer to option A. Aditya Chauhan is also saying option A. So 200 are actually spam, and so spams are positives here. So as 200 are actually spam, so detects 150, and so you have to find out true positives. So 50 are actually spam, so true positive is 50 here, and then you have to find out false positives, so which are positives but which are not positive but predicted as positive. So 150 have been detected as spams, but only 50 are spam, so that means 100 are not spams. So that means precision would be 50 divided by 50 plus 100, so it will be 50 divided by 150, so it's 33.3%. So this is the precision. Now for recall, you need to know TP divided by TP plus Fn. So you have to know Fn. So Fn, false negatives are positives but predicted as negatives. So there are actually 200 spams, but 50 correct spams has been detected. So that means 150 spam mails have been detected as negatives, that means non-spams. So the false negative would be 150, so it would be 50 divided by 50 plus 150, so which is 50 divided by 200, which is 25%. So 33% and 25%, so option A. So these are the calculations. Now question 7. What is the effect of using bagging on weak classifiers for variance? Option A is increases variance, option B is reduces variance, option C is does not change. So what is the effect of using bagging on weak classifiers for variance, whether variance increases or decreases or does not change? Shankar Lal is saying option B, Raghav option B, Pratik is also saying option B. The correct answer is option B. It reduces variance. So that is one of the advantages of using bagging, that as it combines the outputs of many different classifiers, and individual classifiers might have high variance, but once you combine the outputs of different classifiers, the variance would reduce. So that is one of the advantages of using bagging. So option B is the correct answer. Question 8. You are building a model to detect cancer. Which metric will you prefer for evaluating your model? Option A is accuracy, option B is sensitivity, option C is specificity, option D is MSE or mean squared error. Pratik is saying option C, Raghav is saying option B. So option B is sensitivity, option C is specificity. Anyone else? Bina is saying option B, sensitivity. The correct answer is option B, sensitivity or recall. So in case of disease diagnosis or medical diagnosis or detection tasks, the number of positive samples are very less. So there are very few positive examples. So in case of cancer, there will be very few cancerous cases, there will be many more non-cancerous cases. So in case of sensitivity or recall, we try to compute this TP by TP plus Fn. So that is basically TP by P, which is total number of positives. P is total number of positive examples. So it tries to find out of all the positive examples, how many the model is able to correctly predict as positive. So this is what we want in case of medical diagnosis task, that out of all the cancerous cases, how many the model is able to detect as positives, because negatives would be, there will be many more negative cases. So if we use accuracy as a metric, it would not be very good, because as there are many negative examples, even if the model tries to if the model blindly predicts negative, it would get a very high accuracy value. So that's why accuracy measure is not a very good thing for such tasks or problems where there are very few positive examples. But sensitivity tries to find out that it tries to find out how many out of all the positive examples, how many the model is able to predict as positive. So that's why it would we want to have a higher value of sensitivity in case of medical diagnosis tasks. So that's why sensitivity is the correct answer here. Question 9. So there are two statements, option A, statement A and statement B. Statement A says that boosting takes many weak learners and combine them into a strong learner. And statement B says boosting determines the proportion of importance each weak learner should be assigned and weighs its prediction by it and combines them to make the final prediction. So these are the two statements, and there are four options. First option is A is true and B is true. B is the correct explanation for A. Option B is both are true and B is not the correct explanation for A. And option C is A is true but B is false, and option D is both are false. So which of these four options is correct regarding statement A and B, and also whether B is correct explanation for A or not. Raghav is saying option A, Sankarlal is saying option A. Raghav is saying option D. Pratik is saying combine as in serially. Yeah, serially or sequentially combining the weak learners. The correct answer is option A, that both these statements are true, and B is the correct explanation. So statement A is boosting takes many weak learners and combine them into a strong learner. So it's in every iteration we train a new weak learner. So in every iteration we actually take a weak learner and we combine them sequentially or serially, and we also compute the importance factors for every weak learner based on its accuracy. So option statement A is true, that it combines many weak learners and combines them into a strong learner, and option B is boosting determines the proportion of importance each weak learner should be assigned and weighs its prediction by it and combines them to make the final prediction. This is also correct because we find out the importance factor for every weak learner in every iteration, and based on that we weight the prediction made by that weak learner and then finally combine those predictions into the final prediction. and this is the reason that the by combining the weak learners, boosting is able to create a stronger learner. Because it every iteration it takes a weak learner and it trains it on the examples which have been misclassified before, and based on that it find out the importance values for every weak learner. This way it combines those weak learners and make them into a strong learner. So this statement B is the correct explanation for statement A. So option A is the correct answer. Pratik is saying, I think combine is not the right word as it is a stage wise. So combine, I mean finally you have to combine them to get the output. I mean it happens sequentially. You train the learner sequentially, compute the importance values for every learner based on its accuracy measure. But for the final output for any example, you have to combine the outputs of every weak learner. So this, it has been shown in the class that you have to if alpha t is the importance for the th learner, so and the output for the th learner is this, so you have to combine the outputs of these individual outputs htx output of individual learners, and finally you get the output. So you have to combine the outputs of every weak learner to get the final prediction. Yeah, I mean, so this in the final output, to get the final prediction you have to combine the outputs of all the weak learners. So this is why I'm telling this combine. So in case of bagging also we combine, but that bagging in bagging we don't do it sequentially. We can train classifiers independently and then combine the outputs. In this case the training is not independent for each of the weak learners. They are dependent because we have to give more importance to the misclassified points, and also have to compute the importance for each weak learner. But to get the final output we have to combine the all the learners to get the final prediction. Question 10. Regarding bias and variance, which of the following statements are true? Models which overfit have a high bias, models which underfit have a low bias, models which underfit have a high variance, models which underfit have a low variance. So this question can have multiple correct answers. Raghav is saying option B, Shankarlal is saying A and D, Pratik is saying B and D. Okay, so I have got 3 different answers from 3 different persons. The correct answers are B and D. So in case of overfitting, we know that if the model is overfitting, in that case the model will have low bias, high variance, and if it is underfitting, in that case the model will have a high bias, low variance. So option B is overfit, the model which overfit have low bias, and option D is model which underfit have low variance. So these are the 2 correct answers here. So overfitting is associated with low bias, high variance, and underfitting is associated with the high bias and low variance. Raghav is saying there can be scenario where undrafted models perform poorly on train as well as test data. D is not always true, right? I mean, yeah, any of these four might not be true in some scenarios or some cases. But generally, if the model is overfitting, we expect it to have low bias, high variance, and generally, if a model is underfitting, we expect it to have high bias and low variance. So it might happen in some special scenarios or cases these are not true, but generally these are the cases. Question 11. Considering the AdaBoost algorithm, which among the following statements are false? So you have to find out the false statements, not true statements. Option A is, in each stage we try to train a classifier which makes accurate predictions on any subset of the data points where the subset size is at least half the size of the dataset. Option B is, in each state we try to train a classifier which makes accurate predictions on a subset of the data points where the subset contains more of the data points which are misclassified in the earlier stages. And option C is, the weight assigned to an individual classifier depends upon the number of points correctly classified by the classifier. Option D is, the weight assigned to an individual classifier depends upon the weighted sum error of the misclassified points for that classifier. So there can be multiple correct answers for this question. Pratik is saying D and B. So we have to find out the false statements, not the correct statements. And Raghav is saying A and C. And Pratik is saying A and C. Yes, so correct answers are A and C. So A says that that the subset size is at least half the size of the dataset, which is not true. The correct thing is that the subset contains more of the data points which are misclassified in the earlier stages. So option A is not true about AdaBoost, so this is a correct option. And option D is correct about AdaBoost, that the weight assigned to an individual classifier is the weighted sum error of the misclassified points to that error for that classifier. But C is not correct about AdaBoost, so C is also a correct answer for this question. So A and C, these are the two correct answers. Question 12. We have a dataset with 1000 samples and 5 classes for classification. What would be the training size for a 20-fold cross validation? So 1000 samples are there and there are 5 classes, and you have to do a 20-fold cross validation. What would be the training size if we try to do 20-fold cross validation? Pratik is saying option D, Sankralal is saying 950, which is option D, Mishti Pandey is saying D, Vinay is saying D. So all the answers in the chat are option D. Aditya is also saying option D. Yes, so correct answer is option D. So it doesn't depend upon how many classes are there, and it simply depends upon how what is the value of k in case of k fold cross validation. There are 20 folds, so and 1000 samples, so every fold would contain 50 samples, and first 19 folds would be used for training and the last fold would be used for validation. So 19 folds would contain 950 samples, because each fold is containing 50 samples, so 19 folds would contain 950 samples. So 950 is the training size. So model would be trained on 950 training samples and it would be validated on 50 training samples on the of the final fold that is not used for training. Question 13. Which of the following are true for precision, recall, accuracy? Final option is also recall. So multiple options may be correct here. Pratik is saying AB, Sankalal is saying AB, Vinay is also saying AB. The correct options are A and B. So precision is TP by TP plus FP and recall is TP by TP plus FN. These two are already known, so this is certainly not correct. And for accuracy, this formula is not correct. Accuracy can also be computed using that confusion matrix or the values from TP, FP and TN and FN, but this formula is not correct. So accuracy I think would be TP plus TN divided by all the values, TP plus TN plus TP plus TN, TP plus TN plus FN plus FP. So this denominator contains basically all the examples and the numerator would contain all the correctly classified examples, so true positives and true negatives. So these two components represent all the correctly classified examples. So this would be accuracy, but this option is not correct because there is a factor of 2 that is multiplied to it, so this option is not correct. So that's why the only two correct options are A and B. So these were the practice problems that I wanted to discuss today on the week 7 topics. And now if you have any questions or doubts regarding any of the questions that I discussed today, you can ask. Pratik is saying different K and K is a thousand. Yeah, I am also not aware of this, how this rule comes up. I don't also remember this formula for K, that n to the power 2 divided by n plus d. I can't remember if I have read this formula anywhere, so I don't know about this. So k should actually be selected based on experimentation. So you start with 2, 3, 4, 5, and where you find out that it is no more improving the performance of your model, you can stop there. So this is how it is done. I'm not aware of any such formula for value of k, as you have mentioned n to the power 2 divided by n plus d. I don't know any such formula. It might be there, but I'm not aware of this. So if there are no other questions or doubts, then we can end this live session here. Thank you everyone for joining, and we will again meet next week for another live session. Thank you everyone.